Hi everybody, welcome to today's webinar. We will talk a little bit about Creo Simulate Live. So, just a quick agenda, what we'll be discussing today. So Simulate Live, it's just a simulation tool that's new in Creo. It's available in the latest versions of Creo 4, 5, and 6. So just the agenda, I'll do a few slides on boundary systems, then a few slides on Simulate Live, then we'll go into a demonstration, and then afterwards we will have a question and answer session. So think about those questions. You can ask them as I work my way through the presentations or the demonstrations, and then afterwards I'll answer that. So just use the question pane in the GoToWebinar panel. Okay, so my name is Pierre Venter. I'm a boundary systems technical specialist. I've been working with PTC products for about 8 to 9 years now. And yep, it's my privilege to present to you today about Creo Simulate Live. So just quickly, some of the logos of some of the customers that we serve. I think some of the capabilities where we help them with is product lifecycle management. We help them with data management. Then we also do CAD design and consulting. We do simulations for them, and then we can also help you, and we are helping these customers with product development. So just some of the accreditations we have. I think the PTC ones here are the important ones. So we are a Winchell certified implementer. We're also a PTC preferred service provider, and also a certified training partner for PTC products. Some of the solutions we offered. So I think the main one here is PTC. We also do solid thinking, Iterate, and ZWCAD. Okay, so let's go on to what is Creo Simulate Live. So I think it's really an exciting tool. It can save you a lot of time in the simulation phase of your designs. So I think what I want to highlight in this slide is that first section where you can use simulation in your concept design and even in the early design stages. Okay, so I've prepared a slide later on where we're gonna compare your method that you're using now and how you can use that with Simulate Live. So a really easy tool to use early in the design changes. So you don't have to be a FEA super user or something like that. Anybody can use this. Okay, so use it early in your design, and you can get some really valuable information from that. Okay, so what can you do with Creo Simulate Live? So we can do static structural analysis. Okay, so used to determine the structural integrity of components, and we use that. So it's a normal simulation tool. Then we can also do thermal analysis. Okay, and we can also do modal analysis, okay, with this tool. So all of this is basically done in that early design stages of your product development. Okay. So just some PC requirements that's really important for this product. So you need a NVIDIA Coda enabled graphics card. I'm using a 4 gig of RAM card on my machine currently. They recommend for optimal performance 8 gig card. Yeah. Then there's also a utility you can download when you go to ptc.com. It's just a small executable file that you run. It's going to check your drivers and your graphics card, and it's going to pop up and tell you, yes, you are okay to use the product, or no, you can't. From that same web page, you can also download a trial version for Simulate Live. Okay, so just a little bit about the product. So PTC and ANSYS partnered up doing this, and so the technology itself is was developed by ANSYS, and we're putting that technology into Creo, and that will enable us to use the simulation tool, as you will see in the demonstration. Okay, so now you might have a question. Okay, so where does that leave the normal Creo Simulate versus the this new tool? So, like I said before, this is just a tool for early in your design changes. It's fairly quick to use, and you can basically run the analysis while you are designing your product. Okay, so what PTC has done is they've compared some of the Simulate Live results with normal Creo Simulate. And as you can see there, the maximum displacement calculated by Creo Simulate and Creo Simulate Live, there was a 6% difference on the maximum displacement. And then stress at a certain point, there was a 12% difference. But the important bit is here is that last line, that 10 seconds and 3 hours. So really, can you compare that? Where you would use your normal simulate, maybe you have to change the product a little bit, and then you actually have to go and do the FEA stuff. Where with this one, it's live, it's quick, and you'll get a much better understanding of how your product will react in certain scenarios. Okay, so that's really great and easy to use. So I've talked a little bit about the process that that you will need to change as well, if you will not need to change, but how it will benefit you. So the typical FEA process, you will do your model setup, apply loads and constraints, create the mesh, run the analysis, review the results, modify the model, and then rerun the analysis. Where with the new Simulation Live tool, you apply the loads and constraints. So note, there's no setup and things like that. You run the analysis while you are busy designing this. You review the results, so it's going to give you immediate feedback, and from there you can dynamically keep on reviewing as you make changes, and it's going to feed you that information. So there's no reruns and things like that. So really a great tool in the beginning of your design. Okay, so that's my contact information. So if you have any questions after this webinar, please feel free to send me an email. If I missed your question when we do the question and answer sessions, or you're not happy with the answer that I have, please feel free to send me a mail. Any sales related questions, you'll need to send those to the sales email address as in the slide. So feel free to take a quick snapshot of that and reuse that if you need to. Okay, so let's go into Creo and let's play a little bit with this great tool. So in this first assembly, what we'll do is we'll design a quick bracket, and I'm just going to walk you through the process of this. So the bracket is not a very complex tool, but it's going to but it's going to show us everything that we need to know about the new live simulation tool. Okay, so here's the bracket that will be designed. So I'm just going to activate that, and then I've made some shapes, and we're just going to work through those, and I'm going to extrude that. So let's extrude this to this surface over here, and I'm just going to do the other side as well. So there's our bracket. So it's going to look like that. I think just for clarity, I'm going to open this part on its own. so we can work through the live simulation tools. Okay, so as soon as you grab the license for live simulation, you'll have this extra tab here at the top. As soon as you select on that, it's going to give you a dashboard, and you will be able to see all the constraints, loads, and things that you can apply. So you can also have more than one simulation you can have more than one simulation study within one part. So we can do a structural, we can do a thermal, and we can do a modal analysis as well. Okay, so you can do all of that as many times as you like, right, with different scenarios, different loads, and things like that. So I think for the first one, what I'll do is I'll just fix one of the surfaces. So you pick the surface. So in this scenario, this bottom surface is going to be fixed on the frame of my assembly, and it's going to show you that's fixed. And then I'm just going to add a force on this particular surface here at the top, and that's going to be in bounce force, and then it's going to be in the Y direction, and it's going to be, let's just add 100 pounds on there. Okay, so I've got constraints, I've got loads. So now what I can do is I can start the simulation. So I can either use the quick graphics toolbar, or I can select the icon here on the left hand side. So I'm going to start the analysis, and you would see it's giving me already a result. Okay, so I've done a von Mises stress analysis over here. It's highlighting it here in the bottom. So we could have expected that, sharp edges, things like that. Not really good. So that's going to be a concentration of stress over there. So let's just walk a little bit through the result options we have. So I can change my result type. I can do a deformation, and you'll notice on the right hand side it's going to give it to me in millimeters, my units that I've selected here. So really fairly small, but there is deformation over there. I can do normal X, normal stress, all my directions, and then I can also change how I want to render the model. Right, so now it's showing me all the surfaces. I can change that to be, let's say, the inverse surface. So that's just going to show me the surface behind a certain surface. Okay, so if I turn this model around, it's going to give me that back surface. If I turn it like that, it's going to give me the other surface. Okay, so this is a simple part, but really useful if you're working with more complex things. So let's put that back on surface, and then we can also change our units over here. So I can make it megapascal if I want to, and you notice the legend here on the right hand side will update according to the units that I've selected. Okay, then there's two ways that you can access the animation of the deformation. So you can either do it from here, where you select the icon, or you can pick it in the dashboard. So let's use it over here, and I'm going to play that, and that's how that part's going to react. Okay, so you can increase the speed, you can increase the scale. So that's just going to be a bigger move. So it's just showing that, or I can show true deformations. You can see that's that slight movement. So that would be the 0.184 that you see there. And I can also turn let's make that bigger. I can turn the color bands on and off, and I can also turn it off as it's displayed. Okay, so let's keep that normal. Let's stop that, and let's go back to our design. Okay, so that's the deformation and the results. I can also use the simulation probe, and I can select a certain point, and that's going to give me the value for that point. I can also run a simulation report. Oops, that went to the background. So here you can see all the values and some graphics. Okay, so this can be saved as a HTML file, or and from there you can rename it and do whatever you need to do with that. Take it into Excel and so on. Okay, so let's go and change something in this model. So what I can do while my simulation is running, it's still active. I can go to model and I can add some things in here. So let's first add a round. And let's see what's going to happen. So as soon as I finish that round, then my simulation updated with that geometry. So all is happening while you are designing. So that round didn't really help that much. So maybe we should try a rib. So let's delete the round. And let's just add some data, add my data points, and let's do a rib. I'm just gonna add a reference for that surface, and let's just from that point to that point, and let's give it about 30 degrees. My rib should go in that direction, and let's make it 3 millimeters thick. Okay, so as soon as I finish that feature, there's the simulation updated with the rib in there. Okay, so there's a little bit of a weak point creating there now. So let's pattern this. Let me just, yep, I picked the right thing. Pattern that. I'm going to do a direction pattern. And my distance should be 15. And I want 3 ribs. Okay, and my simulation updated with that new geometry that I added. Okay, so I can see immediately my ribs are off center. I'm not getting the same results over here. So that 15 millimeters that I've added should be a little bit more. You can see there's the middle, this rib is off center. Okay, so I can go and I can change that if I need to, or I can just add one chamfer to have this. So let's maybe do that chamfer scenario on this inside here. So I'm going to add a chamfer, and I'm going to make it so I can change both distances. So let's make that 3, and let's make this about 10. And let's see what's going to happen with that stress in the middle. Okay, so that's much better. We're not getting any red in that corners anymore. Okay, so that's great. So this might be a solution. This might fall out of our design range. So then we need to change that. Okay, so let me just quickly go and delete the ribs and the chamfer that I've done. Let's try a completely different shape. So let's edit definition this. I'm not going to use shape 1. I'm going to use shape 2. Let's see what that's going to result in. Okay, so that might work for us. Our stress here is a lot less than the previous shape. not too happy about this, but maybe we can add a chamfer in here to stiffen that section a little bit. That might be an option. Let's edit definition that. Let's go to shape 3 that I've created. Let's do analysis on that. Okay. So we're sitting a little bit higher here. We'll need to change much more on this one. And then let's edit definition. Let's try the last sort of a wavy surface. This one's much higher. Oh yeah, no. So that's taking us up to 50. So okay, so the idea that I wanted to show you is that you can go and you can change as the simulation is running in the background. So you can get those variants of a certain design in fairly quickly, get an idea of what you need to do, and then change your design fairly early. No need to go to a full-blown FEA analysis. Use Simulation Live to get you in the right direction, and then afterwards, when you've settled on a design, you can do the full-blown FEA analysis. Okay, so let's quickly change this one just back to shape number 1. And then you'll notice as we go into, just going to switch the simulation off for now. Let's go back into my assembly. And then now I can use Simulation Live in my assembly as well. Okay, so it works exactly the same way. You tell it what do you want to analyze, what your fixed surfaces are. So in this case, I might have the bottom surfaces fixed. Where's my force? Might be on this front edge over there. It's going to go, let's say, minus 100 pounds. And Z also. Let's make this 200. So force is going to be in that direction, and if I run my simulation, you'll see the results on the bracket and into my frame. Okay. There's a bit of a spot there, so we might need to work a little bit on that. Okay, so same rules apply for assemblies. You'll use it exactly the same way. Apply your forces, your constraints, things like that. Assembly part, exactly the same thing. Okay, so let's go on to the next one that I quickly want to discuss, and that's the thermal side of things. So we've got a heat pipe design over here, and we need to get our heat distribution down to 40 degrees Celsius. So we're going to use Simulate Live in this scenario. So we already have a constraint. I'm just going to edit definition that. So our convection in air is about 60 and the ambient temperature is 20. And let's do a heat flow. And I'm going to select the surfaces here at the bottom. And then that heat flow down there is going to be 90 watts. Okay, let's run the simulation. Let's see. Okay, so for now we are in our design parameters. So if we result options, we are in Celsius. So we're sitting at let's call it 35. Yeah, but that's a little bit of a maybe it's an over design, or maybe the part is a little bit too long, we can, I think we can improve this and maybe use a little bit less fins over here. So let's see how small we can get this component. So I'm going to keep my simulation running. I'm just going to make my pipes here at the end a little bit shorter. So we're sitting on 57 now. So let's go for 49. So this is all driven from relations. So you'll notice as I change this, my other side of my component will also shorten. Okay, so you can see now there's a little bit more heat going into this fins, but we are still within our design. For those fins, it's not going to work like that. So let's reduce them. So I'm going to edit those. I'm going to make my components only 8, and I'm also going to increase the spacing between them. So let's make that spacing, let's make it 6. I'm going to regenerate that. Okay, so you can see we're picking up a little bit heat. Remember, we're trying to stay below 40. So let's just change the other side as well. So we're going to go to 8 components, and we're going to keep the space, make the spacing 6. I'm going to regenerate that. Okay, so now we broke that 40 degrees Celsius that we don't want. So maybe I went a little bit overboard with those fins. Let's add a few back into it. Let's make that 12, and let's make this 4 maybe. See where that's going to get us. Yeah, that's back into that. So let's do the other side the same way. 12, 4. Regenerate that. That's it. Okay, so we took off what 57 to 9. So we took off 8 millimeters. So we reduced this by 16 millimeters, and we are still in our design range. Okay. All using Simulate Live, quick and easy. You get that feedback, and you can change your design. Other things that we could have done, we could have increased maybe the fin lengths here at the bottom. That's also, but I think the biggest area that was concerning was the number of fins and the spacing between them. Okay, so I think that's what I wanted to show in Simulate Live. So I'm going to mute myself for a minute or two. If you have any questions, get those questions in, and then I'll try to answer them. Okay, talk to you soon. Okay, so we have two questions. So the first one is, does it work for non-isotropic like rubber? So no, not at this stage, but I'll gather some information and I'll send that through to you, Eric. And yes, it's only for static. Okay. So yes, Eric, your assumption about static there is correct. Okay, so there's no other questions, so I'll go ahead and end the webinar. Thank you everybody for joining us today. Keep in mind, you can email me if you have any other questions regarding this webinar. Thank you. Goodbye.